Welcome to this video on multiplication and division of fractions. This is the third video in this series that was designed for intermediate level students and to help understanding of what fractions are and how we compose them when we perform any one of the four operations: addition, subtraction, multiplication, and division upon fractions. You'll recall, and maybe from the first two videos, that we looked at number sets. First, the natural numbers or counting numbers, 1, 2, 3, and then the integers, which was 0, plus minus 1, plus minus 2, plus minus 3, and then we extended to the rationals, which are denoted by the symbol Q, and which are enumerated by writing in the following way: P on Q, where Q is an element of the natural numbers, and P is an element of the integers. And from that enumeration we can create whatever fraction we want. So here's how we listed that below. We know now how to express rational numbers as per the statement. Some examples: 1/2, 2/4, 3/6, 5/8, 6/10, 5/4. All of these are examples of fractions, and we're now going to look at how we operate on them under multiplication. So, what are the rules for multiplication? Well, number 1, multiply numerators. Number 2, multiply denominators. And number 3, cancel. But note that we could change the order of these operations so that we start off by cancelling first. That way we multiply smaller numbers rather than possibly huge numbers. So what does it mean to cancel? Let's have a look. Let's have a look at what cancelling means. Let's visualize the following: 4 red discs and 12 blue discs. So on the left we have 4 for the red and 12 for the blue. Now notice that the first red disc maps to the first column of blue discs. The second red disc maps to the second column of blue discs. The third red disc maps to the third column of blue discs. And the fourth red disc maps to the fourth column of blue discs. So each time one red maps to 3 blue. So we can cross out the previous 3 columns of blue and the previous 3 red. So we have just 1 red to 3 blue. So our ratio becomes 1 to 3. So that's what we finished with, 1 to 3, as we see. Let's try another example, this time with green and yellow. So we have 2 green discs to 8 yellow discs. Now notice that the left-hand green disc can map to the top row of 4 yellow discs, and the right-hand green disc can map to the bottom row of the 4 yellow discs. So each time 1 is mapped to 4, so we can cancel. So starting with the previous slide, we have 1 green and 4 yellow, which becomes 1 to 4. So we cancelled down from 2 to 8 to just 1 to 4. So the first ratio we had was red to blue, which was 4 to 12, which is 4 times 1 to 4 times 3, because we had 1 row of red to 3 rows of blue. The 4's cancel, and we're left with 1 to 3. The second ratio we had was green to yellow, which was 2 to 8, because we had 2 green discs to 8 yellow discs. So 2 times 1 to 2 times 4. The 2's cancel, and we're left with 1 to 4. Just a quick rehash from the previous slide. The rules for multiplication were: multiply numerators, multiply denominators, and cancel. But don't forget that we could do the cancelling first. So let's try some examples. An example. Suppose we take 1/2 times 1/2. Well, first multiply numerators, then multiply denominators. So we get 1 over 4. Now let's think about that visually, what that means. It means 1/2 times visually 1/2, which I've represented in a pie chart here. So you can see the red half on the left. So how do we take half of a half? Well, we need to split it in two, hence the horizontal dividing line. Now, half of that will yield 1/4. So that's what it means visually when we take half of 1/2. So intuitively, it's correct. A second example, 2/3 times 1/3. Well, once again, multiply the numerators. 2 times 1 is 2. Multiply the denominators. 3 times 3 is 9. So we get 2 over 9. Now, again, let's look at that visually to see what that means. So we've got 2/3 times, or 2/3 of 1/3. And we can see visually by the pie chart that 1/3 is one segment out of 3. So what we are doing is we're splitting up that one segment into 3 parts. And so now we've got thirds of a third. Therefore, we have ninths of the whole. And so 2/3 of 1/3 gives us 2 parts out of a total of 9. So again, intuitively, it looks correct. Another example, 3 over 2 times 2 over 5. So, if we look at the numerators, 3 2s are 6. Denominators, 2 5s are 10. So we get 6 over 10. But notice we can cancel in this example. So because we have 2 up top and down bottom, they can cancel. So we can divide by 2 up top, divide by 2 down bottom to get the equivalent fraction of 3/5. But before we do that, let's just have a look visually at how this works. So we have 3 over 2 times, in my pie chart, I've got the circle broken up into fifths, and 2 of them are coloured. So I'm going to split everything into halves, 2 blue blocks, each gets split into half, and the 3 white blocks. And so what I'm left with, the equivalent of 2/5 is 4/10. But because I'm multiplying by 3 here, I end up with 6 out of 10 rather than 4 out of 10, which gives me my 3/5 or 6/10. 3 brief notes about multiplication of fractions. We've seen in a previous video that equivalent fractions can be formed by multiplying the numerator and denominator of a fraction by the same number. An equivalent fraction means exactly the same value, just expressed with different numerator, different denominator. So for example, 1/2 is the same as 2/4, because 1 part out of 2 is the same as 2 parts out of 4. That's an example of an equivalent fraction. So let's take an example here. Suppose we have 3/5. Well, we know if we multiply the numerator and denominator by 2, we end up with 6/10. Same value, equivalent fraction. If we take the original fraction, 3/5, and we multiply the numerator and the denominator by 5, we end up with 15 over 25. Equivalent fraction, same value. And by the same token, we can go back to the original fraction or to a simpler form of the fraction by simply dividing. So in the case of 15 over 25, if we divide the numerator and the denominator by 5, we revert back to the simplest form of this fraction, the equivalent fraction of 3/5. This is basically what we're doing when we're cancelling. Instead of multiplying numerator and denominator, we're dividing them by the largest common factor. The second point to make is that when we cancel, when we're multiplying fractions, we've got 2 fractions or more, in this case 2, but it's the same when we have 3 or more. We can cancel vertically with a common factor in the numerator and denominator, and we can also cross cancel, that is from numerator of one fraction to denominator of another. and from the denominator of one fraction to the numerator of another. So in this case, we look at the left-hand side and we cancel vertically. A common factor of 6 and 10 is 2. So 6 over 10 becomes 3 over 5. Now, we know that we can cross-cancel. So we know now we've got a 5 for the denominator of the left-hand side fraction and a 5 for the numerator of the right-hand side fraction. So we can cross-cancel. 5 goes into 5 once. 5 goes into 5 once. So the left-hand side denominator and right-hand side numerator cancel to become 1 and 1. So now if we multiply numerators, we have 3 times 1, and multiply denominators, we have 1 times 2. We could also have cancelled, of course, cross-cancelled first of all, going 5 into 10. 5 goes into 5, 1. 5 goes into 10, 2. So we would have 1 for the numerator of the right-hand side and 2 for the denominator of the left-hand side. Then we'd have 3 over 2 times 1 over 2. So 3 times 1, 3 over 2. Same answer, different order of cancelling. So in conclusion to cancelling, if we're multiplying fractions, see here we have 2, we can cancel vertically, numerator to denominator, and we can cross-cancel from left-hand side numerator to right-hand side denominator, and right-hand side numerator to left-hand side denominator. So we get what an effect looks like in hourglass. So diagonally and vertically, but not horizontally. The last of 3 points I want to make is that when you multiply, if one of the fractions you are multiplying by is less than 1, then that will reduce the size of the other fraction. So your answer will be reduced in scale. So for example, if we consider the first fraction as the scaling multiplier, if it is less than 1, then the second fraction will be reduced. So the answer will be a reduction from the second fraction. And if the first fraction is greater than 1, then the second fraction that we're multiplying, the answer will be increased in scale from the second fraction. So just like with integers, if we multiply 2 by 3, 3 is scaled up because 2 is greater than 1. If we multiply a half by 3, 3 will be scaled down because 1/2 is less than 1. Let's have a look at this visually. We've got 2/3 times 3/4. Now, we know we can cancel. So the left-hand side numerator and the right-hand side denominator cancel down to 1 and 2. The left-hand side denominator and the right-hand side numerator cancel down to 1 and 1. So we have 1 times 1 over 1 times 2, 1/2. So from 3/4, we've reduced to 1/2. So we can see that that's reduced in size, the amount of blue, as compared to what we originally had. Here's a second example where we have a fraction greater than 1. We have 3 on 2 times 2 on 3. Now, we can cancel numerator left-hand side, denominator right-hand side, we get 1 and 1. We can cancel denominator left-hand side and numerator right-hand side, we get 1 and 1. So we get 1 times 1 over 1 times 1, 1 whole. And that's our full yellow disk. And what we had originally was 2/3, because we had 3 on 2 times 2/3. So we had something greater than 1 times 2/3, so 2/3 was scaled up to 1. Finally, we move to division of fractions. So what are the rules? Number 1, change the sign to times. So change the division sign to times. Number 2, invert the second number. Number 3, proceed as with multiplication, as we've outlined before. So let's have a look at some examples. First example, 7 over 2 divided by 1/2. So 7 over 2 divided by 1 over 2. First thing, change the sign to times, invert the second number. Invert means to flip it. So the numerator becomes the denominator and the denominator becomes the numerator. So it becomes 7 over 2 times 2 over 1. Now we can see that we can cross cancel diagonally. So the denominator on the left-hand side and the numerator on the right-hand side are both 2. 2 goes into 2 once, so both of those scale down to 1. So we now have 7 times 1 over 1 times 1, which means we get 7 over 1, which equals 7. And let's have a look visually to see that that's correct. So, if we have 7 halves, we could visualize that as the 7 discs that we have above. Then we're dividing it by 1/2. I've color-coded the 1/2 in blue to differentiate from the 7 red halves. Well, 7 over 2 divided by 1 over 2 means how many times can I fit 1/2 into 7 halves? Well, clearly I can do it 7 times. I can fit this 1/2 into each of the 7 above. Therefore, my answer should be 7, as shown when we multiplied out following the rules. Second example. Suppose we have 4 over 9 divided by 2 over 3. Well, the first thing we know we do is change the sign to times. The second thing we do is invert the second number. So 2/3 becomes 3 over 2. Now, we notice we're fortunate enough that we can cancel. So if we look at the left-hand side denominator and the right-hand side numerator, we have 9 and 3. So 3 goes into 3 once, 3 goes into 9 3 times. We can also cross-cancel with the left-hand side numerator and the right-hand side denominator. 2 goes into 2 once, 2 goes into 4 twice. So now we're left with 2 times 1 over 3 times 1, which gives us 2/3. So again, let's visually check at how we arrived at that answer. Okay, visually here, we've got a pie chart with 9 slices. So 360 degrees divided by 9 equals 40 degrees. Each slice is 40 degrees. There are 4 blue ones and there are 5 white ones. That's what 4/9 looks like visually in the form of a pie chart. Now we have 2/3, which we can see next to that. So 2 pieces out of 3 equal-sized pieces are yellow. But just for the sake of consistency, we can scale that up into ninths by multiplying the denominator and numerator by 3. So 2/3 is equal to 6/9. So 2 out of 3 yellow pieces becomes 6 out of 9 yellow pieces. Now what we're doing is saying how many times or how much of the yellow can we fit into the blue. Well, since we're trying to fit 6 slices of yellow into 4 slices of blue, only 4 of those 6 yellow slices can fit because we have 4 blue slices. So only 4 out of 6, or 2/3 of the yellow, can fit into the blue. Therefore 4 over 9 divided by 2/3 is equal to 2/3, which we showed above with our multiplicative rule. Final rehash rules for multiplication. 1. Multiply numerators. 2. Multiply denominators. 3. Cancel. But recall that we can do the cancelling first to simplify multiplication. Rules for division. 1. Change the sign to times. 2. Invert or flip the second number. 3. Proceed as with multiplication above. Thanks guys, and if this was helpful, feel free to like and subscribe, and I'll be trying to regularly create more content over the coming months.